Alright, these are the answers for I do, you do, factor, distribute, and combine like terms. So I want to simplify, which means I want to get my like terms together to review some things, as if these K's and these K's want to get together, but they're in separate jail cells, or they're not able to get together. We need to bust them out of jail with the distributive property. Leave, change, opposite, distributive property, combine like terms. Those are the 3 steps that I would take. So leave, change, opposite. Distributive property number is busting these out of jail. 5 times 3K is 15K. 5 times negative 4, that's 1 negative in that problem, so that's a negative answer. 2 times 1K, there's an understood 1 in front of that K. Gets you 2K. And 2 times 3 is 6. Now we combine our like terms. Remember, to be like terms, the variable and the exponent of the variable have to match. So 15K and 2K is 17K. And negative 20 and 6, they have different signs, so I subtract sign of the larger. 17K plus negative 14 could be written as 17K minus 14. You could have done the commutative property and had negative 14 plus 17K. Those are all options. Fully factor, that means I want to take out the greatest common factor. So I'm looking at 8G and 20. And the biggest number that fits into both of them is 4. So I want to divide both of them by 4. Factor, remember, is reversing the distributive property. So I divide this one by 4 and I divide this one by 4. So when I take 8G divided by 4, I get 2G. When I take 20 divided by 4, I get 5. And then I put on the outside of that parenthesis what I factored out. I factored out a 4, and we've written it now as a multiplication problem, and you can always check your work by doing the distributive property. I get 8G plus 20, which is exactly what we started with. We've done it properly. Again, leave, change, opposite, distributive property. So let me do that. Bust these guys out of jail. They become a 10G and an 8. Still have a 3G over here and a negative 5. Should be able to see what goes together. G's match G's, so I can add and use that same side since they're all positive. No constants match, or no variable matches no variable because they're constants. So I add, well, they have different signs, so I actually subtract their absolute values and use the sign of the larger. So the positives win it by 3, and we get 13G plus 3. Remember, the 13 is the coefficient because it's what the variable is multiplied by. The 3 is what we call a constant. This is a 2-term algebraic expression. There's your first term, there's your second term. We're not able to solve it at this point unless I knew what G was, or next chapter when we know what it equals, then we could solve it because it's an algebraic equation. But now it's only an algebraic expression. Fully factor. I'm going to do this one in pieces, so maybe you see that a 2 comes out of them since they're both even. So you divide by 2, and you divide by 2. 36 divided by 2 is 18. And 6C divided by 2 is 3C. And what you factored out was a 2. But then you look at it again and you notice, oh, they still have a common 3, so we divide out a 3. When I divide out a 3, the 18 becomes a 6. When I divide out a 3, it becomes a 1C, which I could just write as a C. And remember, now I've taken out a 2, and I've taken out a 3, so I need to take 2 times 3. I've really taken out a 6. So you might write 6 times the quantity 6 plus C. You could have written in a 1C. That 1 generally disappears because that's its identity, of course. Again, leave, change, opposite. Leave, change, opposite. This middle one's the one that I'm worried about. Leave, change, opposite has to stay on the outside. You can't force it into the jail cell. And there's an understood 1 right there. There is an understood 1 right over here as well. Okay? So I'm going to do this one 2 different ways. First of all, distribute. If you're taking it times 1, if you're in my class, I call that a Castle Rock jail cell because I tell a story about a Castle Rock, a friend of mine that was in a Castle Rock jail. But anything times 1 is itself, so that's going to come out of jail as the exact same thing it was in jail. Okay? If you take anything times negative 1, it goes to its opposite. So the opposite of positive 3y is negative 3y, and the opposite of negative 3 is positive 3. Now you can combine your like terms saying, oh, y's match y's. They have different signs, so we subtract sign of the larger. Constants match constants. They have different signs, so we subtract sign of the larger. And you could write 2y minus 7 or 2y plus negative 7. Or, of course, you could write it in a different order because of the commutative property and write negative 7 plus 2y. Any of those are okay. I'm going to show you another way to do this, and that is to line them up vertically. So I have 5y minus 10, go ahead and leave it in parentheses, minus 3y minus 3. Now you got to be careful because remember this minus is what we're doing to the whole thing. So I have to do each piece. So this problem over here is 5y minus 3y, which is 2y. And this one back here is negative 10 minus negative 3y, which of course we're going to do leave change opposite. And now we subtract sign of the larger and it becomes negative 7, which is exactly what we had before. Just a different way of doing it, lining up your like terms and then making sure you subtract both of them.